Welcome to day 3, everybody. We're looking at binomial theorem and binomial probabilities. The first part we're going to look at is the binomial theorem. The binomial theorem is a way to simplify things in terms of our expansion. So x plus 1 to the third should look slightly familiar to you guys. We looked at polynomials back in chapter 5. And back then, you'd have to take x plus 1 and multiply it by x plus 1 times x plus 1 times x plus 1. Then you'd have to FOIL everything out. You'd get x squared plus 2x plus 1 times x plus 1. You'd have to expand even further. I'm going to zoom in a smidge here so I have a little more space to write. So you wind up with, x cubed plus 2x squared plus x squared plus 2x plus 1 after you distribute everything through, and you finish with x cubed plus 3x squared plus 3x plus 1 after you combine like terms. All right? So there's this guy back in history named Pascal, and he noticed as time went by, our combinations we talked about have a specific pattern to them, all right? And he formed what's called Pascal's triangle. Notice to get the next number, you simply add the 2 above it, if that makes sense. So that's how it's formed. We use combinations to form Pascal's triangle. We also can use Pascal's triangle and combinations, or the idea of combinations, to come up with our expansions. Because if we look coincidentally, our coefficients correspond to a specific row in Pascal's triangle. All right, we have the 1, 3, 3, 1. All right, so the first part of the day is all about helping us shorten this process so I can skip all of those steps. I don't have to do the foiling and distributing and combining like terms. I can jump to the end right away. All right, so this looks uber confusing. All right, don't let the notation fool you. Okay, we have a binomial and we're going to expand it, so we're going to use our combinations. So the first thing I like to do is just set up the combinations. We always start at 0. Since my power is 4, I'm going to start at 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. That completes the row in Pascal's triangle. Okay? Then, with the first term in your expression, I'm going to use a different color so you can kind of see. Our first term, we start at the power. So we have x to the 4th, and then we count down by 1 each time. X squared, x to the 1st, x to the 0. Then the second term in our expansion, we start at 0 and work our way up. So 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, and 2 to the 4th. At this point, all you need to do is figure out those numbers. So 4 choose 0 is 1. And then we have x to the 4th, 2 to the 0 is 1. 4 choose 1. If you don't know these combinations, you can type them in your calculator or use the formula. But 4 choose 1 is 4. We have x cubed. 2 to the 1st is 2. 4 choose 2 is 6. X squared times 2 squared, which is 4. 4 choose 3 is 4 times x to the 1st times 2 cubed, which is 8. And then our very last term, 4 choose 4 is 1, x to the 0 is 1, and 2 to the 4th is 16. So when we look, we have an x to the 4th, 2 times 4, 8x cubed, 4 times 6 is 24x squared, 32x, and 1 times 1 and 16 is 16. All right, So we're going to go through that same process on this next example. All right, so first things first, we're going to start with our combinations. We have a power of 4, so I'm going to start with 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. All right, then we go into the first term of our expansion, which is 2x. We're going to have 2x to the 4th. We're going to have 2x to the 3rd. We're going to have 2x squared. We're going to have 2x to the 1st. And we're going to have 2x to the 0. All right, beyond that, we take our second term, which in this case is negative 3. We start at 0, negative 3 to the 1st, negative 3 to the 2nd, negative 3 to the 3rd, sorry, it's getting a little cramped, negative 3 to the 4th. All right, then at this point, you can go through just like we did up above and figure out each combination. So we know it's 1, 2x to the 4th is 16x to the 4th, 3, or negative 3 to the 0 is 1. Then we have 4 choose 1, which is 4. We have 2x to the 3rd, which is 8x cubed. And then negative 3 to the 1st is negative 3. 4 choose 2 is 6. We have 2x squared. We wind up with 4x squared. And negative 3 squared is a positive 9. Then we have a 4. 2x to the 1st is just 2x. Negative 3 to the 3rd is negative 27. And then finally, our last term, 4 choose 4 is 1, 2x to the 0 is 1, and negative 3 to the 4th is 81. So we wind up with 16x to the 4th minus 96x cubed. The 96 comes from the 4, 8, and negative 3, plus 216x squared minus 216x plus 81. So notice it was still a little work to come up with the expansion, the correct answer. But as far as I'm concerned, I would much rather use combinations than have to do this with my expansions. Because this, despite what you're thinking now, might be easier and shorter for you. But if I give you something to say the 6th or 7th power, all of a sudden this method we used back in chapter 6 is no longer effective. All right? So really hone in on using binomial theorem to shorten the process, because I guarantee you I'm not going to give you a degree 3 or degree 4 on your test. All right? Other than that, I think that's it. So look it over, practice, and then we're going to look at a few examples using the binomial theorem next.